Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion is Laplace transform of periodic function. This video lecture, in detail we are going to discuss about definition of periodic function, and we are going to solve problems based on periodic function for which we are going to apply Laplace transform. Definition of periodic function. A function f of t is said to be periodic if and only if f of t plus capital T, which is equal to f of t. The meaning is f of t, it is a definition, that's what in general we have taken f of t. Suppose any function sin x or cos x or tan x, any function, whatever it is, the function, if it is added the period, that is capital T, still it remains, there won't be any changes in the given function. That is the concept of periodic function. That is f of t plus capital T, which is equal to f of t, for which this equation is true for every value of t, is called the period of the function. Otherwise, we can call this a definition in another way also. A function f of t is said to be periodic function of period capital T. That is the period in the function which is added, that we are denoting the symbol capital T. That capital T is greater than 0, that is positive. If, that is, this is our given function, that is f of t. This f of t, we added the period t plus capital T, which is equal to f of t plus the period which is multiplied by 2. The first one, which is multiplied by 1. The next term also we want to write. Then that is f of t plus 3t plus f of t plus 4t plus so on. It continues. The last one is f of t plus nt. The example we can see for this periodic function. Sin t, it is a trigonometric function, and cos t, it is another trigonometric function. They are called as periodic function. We know it. Just now we have seen what is a periodic function. That is f of t equal to f of t plus capital T. If this definition is satisfied for our this trigonometric function what we have taken, then we will call it as periodic function. If it is called a periodic function, in that particular function, what is the period? For sin x, the period is 2 pi. That we will see in detail. Tan t and cot t, another trigonometric functions. Their period is pi. Now, if f of t is a periodic function with the period capital T, then Laplace transform of, that is, the function is given, the function is a periodic function. If it is periodic function, it should satisfy this formula, it satisfied. Then it has a period, that is capital T. Then how to apply Laplace transform? So Laplace transform of this periodic function is integral 0 to capital T. Capital T is the given periodic function period. e power minus st f of t dt. See, if we are looking this, the numerator, the formula, that is Laplace transform formula, we know it, that is integral 0 to infinity e power minus st f of t dt. This is Laplace transform formula. Fine. So e power minus st f of t dt. Then what is the difference between this Laplace formula and this Laplace transform? When we are applying this periodic function, what are the changes are taking place? Always we have to do the comparison study. That will make our self-confidence in studying. Now, so 0 to infinity, it is only the Laplace transform formula. But when we are applying this Laplace transform to the periodic function, that is 0 to capital T, that is very, very important. Fine. Which is divided by 1 minus e power minus s into capital T. So, we discussed about Laplace transform of periodic function. Now, sin x, the previous slide, sin t and cos t, these two trigonometric functions, they are periodic function with the period 2 pi. The sin t, we will see it, how it is a periodic function, how it is written here, the period is 2 pi, how it is written, that is also we can see it. Now, sin x, the trigonometric function we have taken. So, we know the formula, f of t equal to f of t plus capital T. So, sin x, next sin of x plus 2 pi, next sin of x plus 4 pi equal to sin of x plus 6 pi. Now, this if we solve, we know it, sin of x plus 2 pi. The 2 pi, 2 into 180, 360. So, 360 plus theta, the same one will be coming, sin x. Now, this is sin of x plus 4 pi is there. So, we can write it, this sin of x plus 2 pi plus 2 pi. The 4 pi we can split, we can write 2 pi plus 2 pi. So, again it is becoming sin of x plus 2 pi. The previous only, it's nothing but a sin x. So, next sin of x plus 6 pi. That also we can write it. That is sin of x plus 4 pi plus 2 pi. It's nothing but sin of x plus 4 pi. It's nothing but the before the, what is the trigonometric function? It is defined. The next it will be sin of x plus 8 pi equal to sin of x plus 10 pi. So, if you are noticing 2 pi, 2 pi, 2 pi, we are adding, there is no changes. That is, we know it, f of t plus capital T equal to f of t. So, here our f of t is sin x. With the sin x, we added the period 2 pi. Then we are getting again the sin x. So, 2 pi is called period. Then we are declaring the sin x is a periodic function. Similarly, cos x also the period is 2 pi, whereas tan x cot x the period is pi. The similar manner it should be done. Yeah, fine. The function sin x is periodic with the period 2 pi. The t lies between 0 and 2 pi such that sin of x plus capital T equal to sin x. It satisfies our periodic function f of t t plus capital T equal to f of t, where our t is playing the role 2 pi. The period is 2 pi. Now, in a simple way, we can tell this periodic function, the defining a function f of x is said to be of period capital T or to be periodic with period capital T which is greater than 0 if for all real x, that is f of x plus capital T which is equal to f of x. If you are adding the period with our given function which is equal to our given function only, and t is the least of such values. We have to see it that here 2 pi, 2 pi, 2 pi we are adding, which is the least 2 pi. So the 2 pi is playing the role of, the least one is playing the role of period. It is denoted by capital T. So based on this periodic function, we will solve a problem. Find the Laplace transform of the rectified semi-wave function defined by f of t equal to t lies between 0 and pi by w. Then it is sine wt. When t lies between pi w and 2 pi by w, the function is 0. So now we have to read the question from where the interval starts. It starts 0 up to 2 pi by w. So now solution we will concentrate. Since f of t is a periodic function with the period 2 pi by w, the function is sine. Sine period is just now. We discussed how the 2 pi we got it for the trigonometric function sine. So 0 to 2 pi. So the given our sine, the function, our f of t is a periodic function. So periodic function, our given it is there. So Laplace transform of periodic function we can apply for this our given problem. Now, L of f of t equal to 1 by 1 minus e power minus s capital T equal to the integral 0 to capital T e power minus s t f of t dt. This is the Laplace transform of periodic function. Fine. What about our given problem capital T? That is, the break it has given. T lies between 0 to pi by 3, one interval, and pi by 3 to 2 pi by 3 it is given. So 0 to 2 pi by, 2 pi by, w. Pi by w, it is 2 pi by w. Now, so 0 to 2 pi by w e power minus st f of t dt. So 0 to capital T, it should be splitted in such a way according to our problem, because the t lies between 0 to pi by w and pi by w, the t lies between 2 pi by w. So now, for t lies between, when it lies between 0 to pi by the w, it is sine function. That is, f of t is taking the position sine. Whereas, if it lies between this particular interval w pi by w to 2 pi by w, the function is 0. That is a condition which is given in our problem. According to that, the second integral doesn't exist. So now only the interval, the first integral only exists, the second integral doesn't exist. So the first, this one, 1 by 1 minus e power minus 2 pi s by w integral 0 to pi by w e power minus st sine wt dt. This is nothing but 0. Now, when we are looking at this integral, one is exponential, another one is trigonometry. Both combining, we have to do the integral. How to do the integral? If we do the integral by parts, it takes time. Instead, which formula which is available regarding this exponential and the combination with the trigonometry, the formula which is available, we can use it, we can consume our time. So the same, the previous step which is written here again. Now, the formula which is available, that is integral e power ax sine bx dx equal to e power ax divided by a square plus b square into a sine bx minus b cos bx. This is the formula. This is the formula if exponential and trigonometry both combining. This how to apply in our given problem integral. We will do the comparison. This part we won't touch it at all. That we will keep it as it is. Fine. Next, here we will do the comparison. E power minus st is there. Here our formula e power ax is there. That means what about a? A is playing the role minus s. What about b? B is playing the role this w or omega also. Yeah. Now we will apply it. So this part is written as it is. E power minus st. We know it. A, it is there in the formula. Our problem it is minus s. Fine. The formula b is there. Ours is w or omega also. So e power minus e power ax. So a place we substituted. Yeah, 1 minute. Yeah, minus s. Fine. By a square, that is s square, plus b square, that is w square. So here a place we put it, we substituted minus s, sine bx, that is sine wt. The formula, so bx is there, but here t is there. So if you're noticing each and every step, mathematics is very important. Here we are doing the formula, the integration with respect to x. That is the reason here dx is there. Whereas here, integration with respect to t. That is the reason here dt it is there. Fine. Now, here a we substituted minus s. Sine bx is nothing but sine wt. Here this minus is minus. Here the b we substituted w and cos bx, that is cos wt. So now 0 to pi by w. Fine. So now we can see it here. This values we have to substitute it. That is the upper one is minus pi by w. The lower one is 0. E power 0 we have to keep it in our mind. e power 0, the value is 1. This as it is will be written. The t place, we will substitute the upper one, pi by w. So it will become here pi by w. The down part is written as it is, minus s. Here, this place we are going to substitute. It will become sine w pi by w. This cancelled. Sine pi we know it. So completely it is going to be 0. This part minus w, cos w into pi by w cancelled. Cos pi, that is cos 180. Cos 180 minus 1. Minus 1 into minus w, that will become plus w. That we have to be. So we can see it here. So it is written as it is. This is also written as it is. So 0. So minus minus it has become plus w. What about this? This is not at all related to problem sign. That is upper limit minus lower limit. That is the formula minus. Here e power 0. Upper one is we completed up to here. Upper, that is the pi by w. We applied and we got it, this result. Minus this part, it's nothing but the lower one. So the lower one, e power 0 we have to apply in terms of t. In the place of t, 0 we have to apply. So the numerator is e power 0. It is becoming 1 divided by s square plus w square. Next. So in this place, sine 0, 0 minus w into cos 0. Cos 0 value is 1. So minus w. We are going to do the simplification. That is, if noticing here w is there, here also it is there. Put together we have taken out. So w by 1 minus e power minus 2 pi s by w. So e power minus pi s by w or omega, the symbol, s square plus w square plus minus minus plus, already we have taken out. So 1 by s square plus w square. So this part which is written as it is, and this put together, if you are noticing, the denominators are common. So put together we have written as LCM. So 1 plus the denominator, put together we wrote it under the sum, that is the addition symbol is there. So 1 plus e power minus pi s by w. So now this part is written as it is. This is only a simplification purpose. We want to do more, actually the result we want to give it in a simplified form. That is the reason. So numerator and denominator, we are up and down, we are multiplying by the term 1 minus e power minus pi s by w by 1 minus e power minus pi s by w. So the simplification, we are noticing this is written as it is, this as it is, this term and this term put together, that is, this we are taking as a plus b, this term we are taking as a minus b. We know the formula, the algebraic simple formula, a square minus b square is the simple algebraic formula. A is playing the role, our given problem 1. So 1 square. So here it is, it should come minus here, minus, and this, that is e power minus sw, the whole square. It's nothing but e power minus 2 pi s by w. That's what it is written here. So this term getting cancelled. This it is written as it is. This we used for in this algebraic formula. This we didn't touch at all. So that's the reason this is written as it is. So the next step, this will play a role. This will play a role. This will play a role. Whereas this and this they are getting cancelled. So we can see it very clear. So we completed the problem for this periodic function. The sine, the trigonometric function, the period is 2 pi. We used it, Laplace transform, we applied it, and we got this is the final result. We reached it. The conclusion. First, we discussed the definition of periodic function. F of t plus capital T equal to f of t. This is the definition of periodic function. For if it is a periodic function, then we will apply Laplace transform. So the Laplace transform for the periodic function is integral 0 to capital T e power minus st f of t dt. But Laplace transform e power 0 to infinity e power minus st f of t dt. This is only Laplace transform formula, but this Laplace transform formula, if we apply for the periodic function, then it is integral 0 to capital T. This capital T, it's nothing but the period which is completely divided by 1 minus e power minus s into capital T. We have taken one problem, that is t lies between 0 to pi by omega, that is sine omega t, and t lies between pi by omega, that lies between 2 pi by w, the function is 0. This trigonometric and exponential combination, the formula, we have to keep it in our mind. Easy to remember also. It doesn't mean that always. In this problem, this video lecture for the discussion purpose, we have taken f of x is a sine oriented trigonometric function we selected. Maybe cos if it comes, that formula also we have to remember. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.